Hello and welcome. This video will cover the photoelectric effect experiment, in which we are going to measure the voltage and current produced by a photocell while applying a certain filtered light to it. We got two sources of light here, 1 and 2. We got a photocell placed in there with a connection for current. This is the ammeter and it's called picometer because it can measure current down to picoamps. This is a voltmeter in here which gives readings in volts, and here we are getting the different filters. The filters are in 3 different groups. We got numbered filters with just color identification, we got the 3 mercury filters, and we got other filters with a specific wavelength. Now, before we start with the experiment, we'll need to make sure that this picometer is on using this switch and is 0. If there is any 0 required, you will need to use the 0 knob there and adjust it. The experiment will be in 2 parts. Part 1 will be measuring the produced voltage, and part 2 is going to measure the current. In part 1, we are going to set the height between the light source and the photocell to 10 centimeters only. We are going to use a measuring tape to confirm that. We'll need to make sure that the switch of the reverse voltage is switched on the apparatus, which is located in here. Always remember to cover the photocell if it's not being used. In part 1, we are going to place the filters one by one above the photocell and measure the produced voltage. In order to do that, I'll show you an example with one of the filters. We'll place the filter and you can see quickly in here. Without the filter, we got some current passing in there. This current is due to the light, the room light. So as we cover it, it gets dark there and the current comes back to 0. We'll need to make sure that the photocell and the filter are below the lights which we are going to use first. At the first, I'm going to use this light. Then, after we are done with all the filters with light 1, we are going to use light 2 or lamp 2. So, if we switch on the light in here, we can see current readings there. Now we need to measure at this first part, as I mentioned earlier, the voltage. In order to do that, I'm going to vary the reverse voltage till we get 0 on the picometer. Now if we read 0 in here, means the reverse voltage is equal to the generated voltage due to this light through that specific filter, which will be this value in here in volts. Now we'll switch off the light and do the same thing for the next filter. So your result sheet will be basically a column of filters, then next column of voltage generated due to that filter. You can see now the current. I'm going to switch off and on again so you can see that. Now it's reading 0. As I switch on the light, it goes to minus. Then I will need to adjust the reverse voltage again to get that meter reach 0. Now this reverse voltage knob can do more than one turn. So you always need to turn it slowly till you get exactly 0 in there. And you will be getting different voltage values for different filters. So as I mentioned earlier, you will record in one column the filter type, then second column is the voltage produced. As per your lab sheet, you will need to do all these filters with this fixed height as 10 centimeters. Then we are going to cover the photocell we are going to undertake any zero required using the zero knob in there and repeat that one more time. So we are going to use each filter twice and record the voltage. After all that done, we are going to move the apparatus and the photocell to be exactly under lamp number 2. Then we are going to use the filters again, which is all the filters for part 1. So this is basically covers part 1. Always remember the distance should be 10 centimeter, and you should try all the filters for part 1, identifying each filter clearly, either using the wavelength or the color provided on the number filters or the mercury filters separately. Now in part 2 of the experiment, we are going to switch off this reverse voltage in here, and we're always going to get 0 volts in there. We are looking now for the current produced, and in this case we are going to use only one filter. There are 2 certain filters specified in your sheet, which you will need to select one of them. I'm going to show you an example with the blue-green in here. At this time, we are going again to use both lamps separately with this only filter. We'll start with a distance of 10 centimeter. Then we rise up in 5 centimeter steps till you reach the end of this apparatus in here. We got 2 different sets for this experiment, and they're a bit different. So always start with 10 centimeter, use 5 centimeter increments of height, and record your findings. As you can see now, as without light, the ammeter is reading full scale. So in this case, no matter how you change this reverse voltage in here, nothing is going to happen because it's switched off. So we are going to change the scale of the picometer. Now I'm using the scale of 10 nanoamperes. In this case, I need to read the top range. So for 110.1 nanoamperes, I will read always the top range. If I'm using 30 or 3, I'm going to use the lower range. So in this case, I'm reading about 5 nanoamperes because the scale is 10 and I'm reading about half a scale, 5 or 5.5 exactly. But this is again without switching the light. So as we switch the light, this is again going to read full scale, and we'll adjust the scale again, because obviously if there is more light, more current will be generated. So light 1 is on 10 centimeter height on that filter. We'll need to adjust the scale again. Now I'm using a scale of 30 nanoamperes. I'm reading about half a scale. So that means 15. And that is read on the scale below, or the range below, which is 0 to 30. Zero to 30, and I'm reading about 15. To be accurate is 17 nanoamperes exactly. Next, what I'm going to do, we'll use this measuring tape and adjust the height of this to get it up with 5 centimeters. So we had 10, now 15, then next will be 20, 30, 40, and so on with 5 centimeter in increments. You can see, as I go up, the current will be reduced. Again, we are using only one filter in part 2, and we should use both lamps. We finish with one lamp, and then we switch on the other lamp. We place the apparatus under the lamp as much as possible and record the current at each step. Always, while doing part 2 of the experiment, set the height and get the readings with one lamp at the time. For example, if we are taking for 20 centimeter, we'll record the current value for 20 centimeter for lamp number 2 now. Next, we'll do 25, then 30, and so on. Don't try to move between the two lamps at the same height. You might think that will save you some time, but that will give you wrong readings, because as you move around between the two lamps, something like that, you might not return this photocell to the same exact location. You will end up with getting different current values with the same filter at the same height. So always choose one lamp at a time, do your current measurement, adjust the height from 10 centimeter to the maximum possible. Maximum possible will depend on the set of equipments you are using. Then, after you are done with a full set of readings, you move to lamp number 2, move the photocell to be underneath the lamp, and then do different heights. Now, other set of equipment we have might have different number of filters as well. That should be fine. Just cover all the filters you have in part number 1 and choose one filter only in part number 2. So that's basically it. Thank you for watching.